Salutations class. In this video we'll be reviewing the properties of exponents. First property. If we take two items that have the same base, notice both of these have the base of 2, but are to different exponents, and we multiply them, we're going to essentially keep the same base, add the exponents. Next, if we have something to an exponent, and then that entire thing is to another exponent, then what we do is we keep the base and multiply the exponents. Now if we take things that are multiplied by each other and raise them to an exponent, then everything inside the parentheses needs to be taken to that exponent. Notice the exponent gets distributed across each thing. But this only works when we're multiplying the items inside the parentheses, not when we're adding or subtracting. Next property is anything to the power of 0 exponent is equal to 1. Of course, there is an exception for 0 to the 0, but we all know 0 likes to make a lot of exceptions. Next, if we have a fraction where both items have the same base and are to different exponents, then we can simplify it by keeping the base and subtracting the denominator's exponent from the numerator's exponent. Next, if we have a fraction that's entire quantity is raised to an exponent, again we distribute the exponent to both the numerator and the denominator. Now comes negative exponents. If we have something to a negative exponent, that's the same as saying move it to the other side of a fraction. So notice 2 to the negative 3 can be written as a fraction by writing 1 underneath it. If it's a negative exponent, what we want to do is we want to take the base and the exponent, move it to the other side of the fraction, and then make the exponent positive. So notice how the 2, the base, and the exponent have been moved from the numerator to the denominator, but the exponent becomes positive. Similarly, we have here a negative exponent in the denominator. This means move it up to the numerator and make the exponent positive. Now let's try some examples. Here we have two items with the same base, but different exponents. So we multiply, which means we add the exponents. Notice that there's an invisible 1 for our exponent there, which means this should be 7 to the 3rd plus 1, which gives us 7 to the 4th. If you're not quite convinced about this property, what you could do instead is write it out as 7 times 7 times 7, which is 7 cubed, times 7 to the 1st power. Notice we have 4 7s here, which gives us 7 to the 4th. Next, we have a fraction to a negative exponent. So here's what happens when we have a negative exponent to a fraction. First, we want to distribute the exponent to both the numerator and the denominator. So it's 4 to the negative 2 over 5 to the negative 2. Next, remember, negative exponents means switch it from whichever side of the fraction it's on, either top or bottom, to the other side and make the power positive. So I'm going to switch the 4 to the negative 2 down to the denominator as 4 to the positive 2. And similarly, I'm going to switch the 5 to the negative 2 up to the numerator and make it a positive 2, thus getting us our final solution. Now, we have two things inside parentheses that are being multiplied. So again, we want to distribute our exponent. Remember, this only works when we're doing multiplication. So by distributing our exponent, we get 2 to the 5th, and now we have x squared to the 5th. Notice this is an exponent to another exponent. By one of our other properties, this is going to have us multiply the two exponents. 2 times 5 is going to get us 2 to the 5th x to the 10th. Now some more examples. Here we have a variable to a negative exponent over a variable to a positive exponent. So again, negative exponent means move it to the other side. It's in the numerator, so we'll take it to the denominator, leave a 1 there in its place, keep the y cubed in the denominator, and this becomes y squared in the denominator. Well now, notice that in the denominator we have two things with the same base that are being multiplied. That means we can add the exponents, which once simplified gets us 1 over y to the 5th. Again, we have two things being multiplied inside parentheses to an exponent, but this time we have a negative exponent. So here's what we do. First, we want to take the entire thing inside the parentheses and put it in the denominator, and then give it a positive exponent. Next, we want to distribute that exponent inside the parentheses. So that gets us x to the negative 7 times 3. Remember, if we have an exponent to an exponent, we multiply the exponents. And then y to the 4th times 3. This brings us to 1 over x to the negative 21, y to the 12th. Well, we're not quite done because notice we have a negative exponent still. So we want to bring that up to the numerator, make it positive, and then have y to the 12th left in the denominator for our solution. And now we have multiple variables being multiplied in both the numerator and the denominator. Notice that we can split it up between x's and y's. The x's, remember, we're going to subtract the exponents. There's an invisible to the first power over that x in the denominator, so that's x to the 4 minus 1 in the numerator. And then we've got the y's, where we have y to the 10 minus 3. Then the denominator variables go away. So we get x cubed times 10, or times y to the 7th. Now let's talk about scientific notation. Scientific notation defined is a number written in the form of c, some constant, times 10 to the n, where c is a number between 1 and 10, and n is an integer exponent, is considered to be in scientific notation. Let's try an example to make that definition make a little more sense. Pluto is 3,670,000,000 miles from the Sun. Write this number in scientific notation. So notice we want a c that is between 1 and 10. If I look at the front numbers of 3,670,000,000, we can get 3, 6, and 7. In order to make that number between 1 and 10, I need to put a decimal place right here. Now, if I want that decimal place there, I need to multiply by 10 to some power in order to move the decimal place over. Well, I had to move the decimal place from up here, 1, 2, 3, 4, 5, 6, 7, 8, 9 places over. So in order to move it 9 places over, I do times 10 to the 9th. Let's try a slightly different example. Here, a spider silk has a diameter of about 59 ten-thousandths of an inch. Write this number in scientific notation. So again, my important numbers I'll circle are 5 and 9. In order to make this a number between 1 and 10, I need a decimal point there. Well, in order to get a decimal point there, I needed to move it 1, 2, 3 places over. But this time, notice I'm moving in the opposite direction. So I need to move negative 3 places if we want to make the number a bigger number for our c than our starting number was. Notice in the first example, we made our c a smaller number than our starting number. But in the second example, we made our c a bigger number than our starting number. And that's why we used a negative exponent. This has been your review for properties of exponents in scientific notation.